I'm Naval and I'm Chandran Mittal, and we are here to take you through the wireless world. The world is going wireless day by day. The reason being, it helps you get rid of all the complexity of using wires in your day-to-day work. It helps you work on the go. You need not be sitting near a socket anymore. And wireless services are usually one service provider to multiple service consumers, which are quite useful. In this video, we will discuss about one of the innovations of wireless technology: wireless charging.
Now, you do not need wires anymore for charging devices such as smartphones, laptops, etc. Talking about its brief history, wireless charging is being used since the early 1990s in the electric toothbrushes and for surgical implanted devices like artificial heart. Now we have that wireless charging is based on electromagnetism. To understand how it works, we have to go back into 1820s to look at the birth of wireless charging. Danish physicist Hans Christian Ørsted was first one to discover the magnetic effect of current. He placed a magnetic compass near a current-carrying wire. On changing the direction of the wire, the direction of the deflection of needle also changed. He also observed that the direction of needle also depended on the magnitude of the current. He concluded that the current-carrying wire generated a magnetic field around it, which deflected the needle, and electric effects can lead to magnetic effects. The next major development was made by Michael Faraday, an English scientist who believed that if magnetic field can be generated from electricity, then there is a possibility that we can also use the magnetic field to generate electricity. Faraday conducted a series of experiments in 1831 which led to a law called as Faraday's law of electromagnetic induction. In this experiment, Faraday takes a magnet and a coil and connects a galvanometer across the coil. It is starting the magnet is at rest, so there is no deflection in the galvanometer. That is, needle of galvanometer is at the center or zero position. When the magnet is moved towards the coil, the needle of galvanometer deflects in one direction and returns back to zero when the magnet is held stationary at a position. Now, when the magnet is moved away from the coil, there is some deflection again in the needle, but in opposite direction, which again goes to zero as the magnet becomes stationary. Similarly, he observed that if magnet is held stationary and the coil is moved away and towards the magnet, the galvanometer shows deflection in similar manner. It is also seen that faster the change in the magnetic field, the greater was the induced EMF or voltage in the coil. This showed that the changing magnetic field can create an electric potential, which depended on the time rate change of magnetic flux. This deepened the fact that magnetic field and electric field are one and same phenomena under the name electromagnetism. Now, wireless charging technology uses this concept of electricity creating magnetic fields and changing magnetic field creating electric potential to charge the devices wirelessly. The charging pad and the device consist of a coil of wire each. When the pad is plugged into a socket, AC current flows through the coil. A circuit for increasing the frequency of current is then used to increase the frequency. The current then flows through a coil which creates an alternating magnetic field. The device which is to be charged contains another coil which is to be coupled with the pad's coil. This will lead to a change in magnetic flux associated with the device's coil and will induce an EMF in it according to Faraday's law. Now, this induced electric current is then passed through a rectifier and made to DC to store in a battery. The device is now charged with the use of this EMF. Wireless charging seems to be a great idea, but there are some cons with it. First thing is that its efficiency is very low than directly plugging in the device to charge. Another reason is that it has a quite short range. In 2006, MIT, America, found that if we match the frequency of those devices, the power can transfer up to few meters. This is a great innovation, but this technology is not ready yet and the work is going on it. Today, the wireless charging has to go a long path, but it is a great innovation.